All right, this is 5-1. F of x, number 10, the problem number 10, f of x equals this, delta x is 1/3, and we're supposed to figure out this. So we're doing this 6 times. If the width is 1/3, we're going to go for 2 units, because 6 times 1/3 is 6/3 or 2. And f of 1 plus a delta x, 1 plus 1/3 would be 4/3 into f of x. So we got to put that into here. So we're going to have the square root of 4/3 squared plus 1 times 1/3, but they're all times 1/3. So I can do that at the end. And then I've got to figure out, put in 2, and so I'm going to have another third added. So it's going to be 5/3 squared plus 1 times 1/3. And then I'm going to put in I equals 3. So 3/3 is 1. So that's going to be 6/3 or 2 squared plus 1 times 1/3. And then another 1/3. So that's 5/3, 6/3, 7/3 squared plus 1 times 1/3. And then I'm going to do, let's see, this would be 5 in there. 5/3 plus 1 is 8/3 times 1/3. And then I got to do it last time, 9/3 or 3 squared plus 1 times 1/3. Then I got to add them up. Now to do that, I think I would use my calculator to do this quickly. I could go to my tables. Clear, I can just go, or to my list, stat, edit, and I can put in 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. Okay, and then in list 2, I can tell it to take the square root of the numbers in list 1 squared. Oh, I have to add 1 to them. Whoop. Go back here. Parentheses 1 plus the numbers in list 1, because it said 1 plus each of those. And list 1, close parentheses, squared, and then plus 1 outside of that. So 1 plus 1/3, and then 2/3 and 3/3 and 4/3, all those squared plus 1, and times 1/3. And so there's list 2. That's all of these figured out, and now I just have to add those up. So I'm going to go to the second list, second list, operations math, and I'm going to find the sum of, oops, I don't want to put it in there. Clear that. Going to go to quit this and go to list, second list, math, sum of list 2. And so the answer to this problem is 4.798. Okay, this problem, we're supposed to find the area using, and it looks like these are all midpoints of the intervals. So I've got to put in 2.5, negative 2.5, negative 1.5, negative 0.5, and then 0.5, and then 1.5, and 2.5. I got to put those into that equation. I'll do that again on my lists. Stat, edit, and I'm going to go over here. I'll go up, clear the list, come down, go up and clear the list, come down, and I'm going to put in negative 2.5, negative 1.5, negative 0.5, 0.5, 1.5, and 2.5. There's all 6 of them. 1, 2, 3, 4, 5, 6. And I got to put them into this equation, which means I'm going to do parenthesis 4 minus the number in list 1, close parenthesis, divided by, open parenthesis, 1 plus what's in list 1 squared, close parenthesis, and there's all of those numbers in list 2. So then I quit, and then I got to find the sum of list 2 again, and this time that sum is 9.9649. We're supposed to write this thing in summation notation. Well, if I simply start I at 4, it would be I to the 7th, and then it would be 5 to the 7th, 6 to the 7th, 7 to the 7th, and up to 8. So if I went from 4 to 8, and I did I to the 7th, this would be the summation notation for that. In this one, if I let I equal 1 and I equal 2, that's the number on the top. And then on the bottom, if I is 1, that's 1 more than I. And that's 2 more than I. And that's kind of what it said right here. So the summation would be I going from 1 to n. The number on top matches I. The numbers on the bottom are 1 more than I and 2 more than I. So if I is 1, this would match this. If I is 2 in this, I get that. If I is 3, I would get the next one. When I gets to n, this matches this. T5, trapezoidal. I'm doing this one. I'm going backwards on 18. Jumping back because some of you forgot to do the trapezoidal. So I want to explain how that goes again. 5 from minus 1 to 1. So that's 2 from minus 1 to 1. That's 2 divided by 5. So I got to jump by 2/5. All right. So the width of the interval is 2/5. And the trapezoidal, I take if I were to graph this, I'm going to have a breaks at minus 1, minus plus 2/5. Minus 1 plus 2/5 is minus 3/5. The next break would be at minus 1/5, and then the next break would be at 1/5, and the next break could be at 3/5, and then I'd have 1. So there's 1, 2, 3, 4, 5. And then I would have to find, for the trapezoidal rule, I want to take the average of the heights at each side here. So I'd have f of minus 1 plus f of minus 3/5 divided by 2. Then the next one would be the average f of minus 3/5 plus f of minus 1/5 divided by 2. Then f of minus 1/5 plus f of 1/5 divided by 2 plus f of 1/5 plus f of 3/5 divided by 2 plus f of 3/5 plus f of 1 divided by 2. So that's what I'd have to calculate. And I've got it laid out here, so all you have to put in is -1 into this, figure that value out, put -3/5 into this, figure that value out. You can do those on the calculator pretty easily, and then add these, divide by 2, add these, divide by 2, and so on. Okay. This said add the numbers. This says if j starts at 101, then we're going to put 101 in there and get 101. Then we're going to get 102. Then we're going to get 103, etc. up till j becomes 200. Well, we don't have a formula when it starts at 101. We do have a formula if it started at 1. So we could find the sum as j goes from 1 to 200 using a formula, but that would include the numbers from 1 to 100 along with these that take it up to 200. So if I figure that out, and then if I figure out what the sum is from 1 to 100, all these numbers, I could take this away from 1 to 200 and get the answer from 101 to 200. And the formula for it starting at 1 and going to 100 is n times n plus 1 over 2, and 200 is n, so this would be 200 times 201 divided by 2. This one would be 100 plus 101 divided by 2. And so if I figure out this answer and subtract them, I should have these numbers here. And so if I figure out this, see, that'd be 100 times 200 divided by 2 is 100 times 201, which should be 20100. This would be 5050. So if I subtract those two, 20100 minus 5050, I get an answer of 15050 for the sum of the numbers from 101 to 200. All right, it said go from 0 to 50. Well, this is a product. We can't split that up, but we can distribute the j, so this would become the sum of j equals 0 to 50 of j squared minus j, and if we distribute that, then we can just split up this addition or subtraction to the sum as j goes from 0 to 50 of j squared minus the sum as j goes from 0 to 50 of j. Now, if this was 1 to 50, we have a formula. Well, if we're going to go from 0 to 50, we can put in 0, get that one, and then it would be 1 to 50. If I put 0 into j squared, I get 0. So it's going to be 0 plus j from 1 to 50, so I could change that just to a 1. Same here, if I put in 0, I get 0, and then next one would be 1, and that's going to give me something. So I can change those to 1s, and then we have formulas for those in the book. It says the j going from 1 to 50 of j squared would be 50. Let's see here. I'm going to get the formula. Make sure on the squared one. I'm a little iffy on that one. Where is it here? There it is. For the j squared, It's n to the third over 3, n times n plus 1 times 2n plus 1 over 6. So it's 50 times 51 times 2 times 50 is 100 plus 1 is 101 over 6 minus, and then this one, if I put in this, it's n 50 times n plus 1, 51 over 2. That's that formula and that formula. So I have those two formulas. I can just calculate this, subtract that, and I'll have an answer. Okay, now I have to do a limit on 45. Well, n to the third is a constant. That's the n, so I can pull that out of the summation. I can't pull it out of the limit, but I can pull it out of the summation. So I get the limit as n goes to infinity of 1 over n to the third. And then I'd have the sum of three things either subtracted or added, so I can split that up. So I'm going to have the sum as j goes from 1 to n of, or I guess that's I goes from 1 to n of I squared minus the sum as I goes from 1 to n of I plus the sum as I goes from 1 to n of 1. Now, this will be the limit. Let's see, I'm going to need more room here. The limit as n goes to infinity, 1 over n to the third times. The I squared formula is when it goes from 1 to n, again, is, I'm going to use this form now, n to the third over 3, n squared over 2, and n over 6. N to the third over 3 plus n squared over 2 plus n over 6. That's what this one is. Then we got to subtract this one, and the one for I is n squared over 2 plus n over 2. But I'm subtracting all of this, so it's minus this and minus that. And then I'm adding 1 n times, so that's just n. Now, if I divide all these by n to the third, then I have the limit. I could combine like terms, but I'm not going to worry about that. I'm going to have n to the third divided by n to the third, so I'm just going to have 1/3. Then on the rest of these, I'm going to have an n left in the denominator. I'm going to have 1 over 2n plus 1 over 6n squared minus 1 over 2n minus 1 over 2n squared plus 1 over n squared. And as n goes to infinity, all these with n in the denominator are going to go to 0. And so I get limit of 1/3, which is 1/3. Okay. Now we have to do right on this thing from 1 to 4. So we want to do the limit as n goes to infinity of the sum as I goes from 1 to n. The width of the interval will be 4 minus 1, 3 divided by n times each one of these. And then I have to be on the right side. So if I've got 1, And here's 4, and I split this up into a whole bunch of pieces. Each one of these is 3 over n wide, and I want to be on the right side. Then I have to go f of the first one is 1, the last one is 4. I have to go 1 plus 3 over n to be on the right side. 1 plus 3 over n for the first one. And then for the second one, I want to go 2 3 over n's. So I'm going to do I 3 over n's. So that means I got to plug this in for the x in f, because I got to find the height of these at each of these places. And this is a graph that's increasing, so I got to find the height here and the height here and make these rectangles that are the right side, height here, etc. So this is going to be the limit as n goes to infinity of 3 over n times the sum as I goes from 1 to n of, now I put this into here, so I got to take 3 times this, so it's going to be 3 plus 9 over ni plus 6. Okay, so then this would be the limit as n goes to infinity of 3 over n, and 3 and 6 are 9, and n nines added up is 9n. So that takes care of this and this. And then I'm going to have plus 9 over n times the sum from 1 to n of I, and I would be is n squared over 2 plus n over 2. Using this, the sum of j is n squared over 2 plus n over 2. Okay, so if I distribute this 3 over n to this, I get the limit as n goes to infinity. 3 over n times 9 n is 27, and the n's cancel, plus, now if I take 3 over n times 9 over n, I get 27 over n squared times n squared over 2 plus, the n's will cancel on this, plus 9 over 2. Excuse me. N squared over 2 and n over 2. Now I got to take, this was times that. So now I got to take this times this. And so I'm going to have the limit as n goes to infinity of 27 plus the n squared to cancel here, be 27 over 2. And then on this one, I'm going to have 27 over 2n. And as n goes to infinity, that one will go to 0, and I'll get 27 plus half of 27. So half of 27 is 13 and a half. On to 27 is 40 and a half. Okay. And I'll do 51 in a moment.